We're back. If you can't, then we're not. But I don't know what happened there. The internet had a bit of a funny, so the stream stopped, which was handy. Lucky I noticed actually. But yeah, did we go any further than where you got to just there, Cliff?
No, we're at a pretty good picking up pretty much right where we left off. So Cliff has pulled down the Debian package for Deepstream and is currently installing that. So that's mid-process. It won't take too long for that. But one of the interesting things to note here in the installer, there is a link there that says website. And Cliff's already gone ahead and clicked on that. This is a good place if you do want to, find more details, information, getting started guides, just in general about the Jetson platform and that sort of thing. This is a one-stop link that'll sort of bring you to places like the forums, also give you a full rundown of certain projects that have been built by the community for doing certain things, news, general news, and that sort of stuff. So definitely would recommend checking that out if you just don't know where to start. Once you've installed this, that should give you some ideas. Once we get that,
it's a free course as well. Is that the Deepstream course that you were talking about before?
Yeah. So if you do click on that, that will take you to the Deep Learning Institute, where you can enroll in the Getting Started with Deepstream for Video Analytics on Jetson Nano. Now, I would recommend to anybody that you take this course. It actually is going to make a lot of sense after what we talk about today. They sort of teach this. It's good that they tackled this. They teach you from the C SDK portion how to build Deepstream pipelines. So you will truly understand what this thing is doing underneath the hood. What Cliff and I are going to do today is a bit more higher level. We'll be working with the configuration file approach, which behind the scenes we'll be leveraging a bunch of C libraries and things like that make it all actually work underneath the hood. But if I was to suggest the best way to learn Deepstream, I would say learn the config approach first, then go back and look at the C stuff and how it works. It's almost, maybe that's a personal preference, but I kind of feel like if you start from the bottom up, you might get so stuck in the weeds that like you turn around and you don't venture forth any further. Versus what we're going to do today is like very easily enabling. So like, being quite blunt, if you can wield a text editor, you can create an accelerated intelligent video application pipeline. So,
Notepad++.
Yes, yeah, that's all you need. So you have installed the Deepstream SDK. Now this is the fun part. If you head into your terminal, or you can choose to head into your file explorer, really either one, it doesn't matter. It might be
if I go into file explorer, because the you mean the terminal on the Jetson?
Yeah, the terminal on the Jetson or the file explorer, just in general, either or. File explorer might be easier to see, but we'll eventually be doing both. But for what I want to, if you click that, that should open it. So if you click over there on where it says home folder, all the way up at the top.
There you go.
It's not exactly what I was wanting to see. Go up to the navigation bar, and what we're going to do is navigate to /opt/opt.
On the back of that one, yeah, or not in the home?
Like back it all the way and just go to /opt, so like root opt directory.
There you go.
And you should see a directory called NVidia. And inside there should be a folder called Deepstream. Now here, we'll just park for a second. There are two folders here, Deepstream and Deepstream with a version number appended to the end of it. And from what I understand, all versions of Deepstream after like 4.3 do this. The Deepstream folder itself is a symlink to whatever the current version of Deepstream is that's installed. So in this case, version 5.1. This is important because, as you'll see, especially when we get into the config files, they will reference things that go to the Deepstream directory. And so if you ever do have like a version mismatch, it's sometimes good to know that this folder exists here. Like, let's say you have Deepstream 6 alongside Deepstream 5, and you're referencing things that used to work in 5.1, and you're using the Deepstream symlink, but now that symlink points to 6 and things don't work. It's just good to know that. But also, on the other hand, I find it makes your config files a lot more portable and readable. Most of them will just work if you just always use /Deepstream. There are some inconsistencies there if you really get into the version intricacies, but just know that. So you can click into either of those directories and it will take you to the next place.
Either one, yeah?
Either one, yeah. And inside this directory structure, you're going to see a few things here. So you'll see like a bin folder. And I don't know if we can somehow make that larger text. I don't know. For folks out there in the view, is it possible that we can make that?
We
It'll
should be able
Right for
to.
me.
Zoom in.
There we are.
there
Control
we
plus is it or something, or Shift plus or something.
Control, and I'm looking for plus on this little mini keyboard.
Probably got to hold 16 different buttons down to get to plus.
I haven't got enough fingers.
You wouldn't
It
make
might
a
be
very
easier
good
just to
Vulcan
go.
to the menu.
Now you can totally.
There we go.
That's a lot better.
That should be bigger.
You could totally like read the Deepstream documentation online, and you'll read it for days, and I would not recommend that. I find the best way. It's actually great documentation. It's just not going to let you. It's not going to make it very clear what things are and where they're at. So my first suggestion, if you do pull this down, is like start exploring the folder structure so you can sort of understand what is making this work. So let's go start over on the right, that sources folder, and take a look at what is inside there. And you should see here quite a few things like apps, object detection, and that sort of thing. This is the source code for any of the pre-built binaries that we're going to leverage here in just a moment. So if you were just wondering, like, how did NVIDIA build this app that does this accelerated inference processing and stuff like that? This is all of the source code that makes that happen. So if we go ahead and back up one, that is arguably the most how can I say complex directory that we'll be seeing here. You'll see too that you have a bin directory. If you go ahead and click on that, that is the resulting built binaries from the sources we just looked at. So inside here, you're going to see a number of applications that say things like Deepstream Test App or Deepstream App. These are applications that have been built that can take in configuration files and will automatically set up a Deepstream pipeline for you. So you'll see there's quite a few of these that exist. Now, the naming convention on these is a little bit odd in terms of what they do. So, for example, Deepstream Test 5 is actually Deepstream with Microsoft Azure IoT Hub support. It would be nice if it had a bit more descriptive name, but the Deepstream Test 5 app. Now, you might be wondering, Paul, how do you know that? So if you go back one more directory, I believe there is a docs folder, and I think this is where we want to look, or a doc folder. And if you click inside there, is that NVIDIA Tegra, and you click inside there. This may not be, okay, this is for the licenses for Tegra. So you want to go back. Sorry, I was looking in the wrong place. It's actually in the sources directory that we were just in. So These source files actually do have some use. If you click there on apps, and I just want to make this this point here, just giving this one single example. Go to sample apps, and you should see the Deepstream Test 5 folder. And inside there, down on the third row,
Yeah.
And there should be a README for this. Now, this is how I found out what this does. So if you actually scroll through here, it will tell you things like what this truly does. So you see it says details on the IoT, Kafka, Azure, AMDP. So this Test 5 app is essentially a Deepstream processor that has an added capability of speaking to Microsoft Azure through its IoT Hub MQTT interface using something called an MQTT broker. All that it's really doing, I know it sounds simple to say this, is it is the typical Deepstream app, but it has been compiled with the MQTT GStreamer plugin so that it can take inference results and push those back up to a cloud endpoint. So
when it's taking the results, it's not actually sending the images up; it's sending the output. So if you're counting the number of people it's counting.
Correct. It'll send like what it saw, in a frame, so whether that was dogs and people. And for each one, it will assign a number depending on whether tracking has been turned on. And it will also send the bounding box coordinates in a left up, right down format, I believe. Left up, right. Yeah, sounds right. So this is, as you're just looking at this, I'm teaching you more or less how to navigate this stuff, how to diagnose things if you don't know how they work. So the only two Deepstream binaries that we will be using over today and next Thursday is Deepstream App and Deepstream App Test 5 are the only ones that we'll be using. So this one and one other one that we just haven't looked at yet. So cool. We can go ahead and close that. Let's go ahead back to the directory structure and we'll show a few more things. So what's nice about this is they give you these just like pre-compiled samples that we can really just go to town with. So we'll go up one more. Yeah, we're still in sources. Lib directory is obviously going to be the pre-compiled shared objects that Deepstream may leverage. So we can just look at those real quick, and then we'll get into the fun part. Yeah, so you should see a bunch of .so or shared object files here. If we back out of that, we'll go to the fun directory, which is the samples directory. And a few things to notice here. We'll start with the most basic one, which is streams. So just go ahead and jump in there. This is where a number of multimedia assets, like video files, are stored, and audio files that are used by some of the pre-supplied Deepstream configurations. So you'll see that, these are some input files that we'll be able to perform some inferencing on without necessarily having to connect to an internet hosted feed. But don't worry, we'll look at how to do that as well, hopefully before the end of the day. So if you back out of this one, we'll go to the next most interesting piece, which should be the models. So models, yeah. Now, inside here, you'll see a few things, and it kind of gives it away a little bit what's going on here. You'll see primary detectors, secondary detectors. There's also something called segmentation and what looks like an audio classifier. So primary detectors are when you are doing inference on a video stream, there's always something you need to find first. And so the first thing that fires is a primary detector. So think if you wanted to build a system that like looks at people's license plates at a bank drive-through, your primary detector would probably be, is it a vehicle? Then what we do to employ what's called cascading inference, you would use something called a secondary model to do something like, what's the make of that car? What's the model of that car? Where's the license plate? What does it say? And so that's kind of the difference between primary and secondary. Segmentation is a bit different, different bag of tricks all in of itself. You've probably seen this before. Rather than drawing a box around the region of interest where an object may be, it can actually color and segment out the object in question. So if that is a building or something like that, you've probably seen that like on Google Maps where it can just color the building. That is typically using segmentation for that. And in this latest release of Deepstream, there's also now support for audio classifiers. So meaning that you can take an input from, say, a microphone and be able to determine things from that, like is the dryer running or not, whatever that happens to be. So we'll take a quick look inside one of these folders, Cliff. If you go ahead and check out the primary detector folder, just to give a quick overview on what you'll see here. So primary detector in this case, we're using a calibrated TRT, which means that's like the compiled model, if you want to think about it. Labels.txt, which will tell you what that model can detect. The format of this particular model is using something called Cafe. And then you have the proto text file, which is additional metadata that's used by the processor. So Cafe models are interesting. It is one of many formats for doing object detection. And sadly, in the world of object detection algorithms and AI, there's not a standard format. So we do get close to that with something called ONNX, the Open Neural Network Exchange, which Deepstream does have support for. But in this particular example that you're looking at, this is a Cafe model. And what's nice about Deepstream in general is it can support a number of different models out the box. And if you back out here 2 directories, and we go right back to where we were in that models folder, the really good news, but unfortunately,
you're going to go to that one, don't you?
The good news, no, you can go up one more. Yeah. The good news is that there is a new service that's called TRTIS, so the Triton Inference Server. And you'll see that over there on the right. Unfortunately, though, I don't think that this works on the Nano. At least it did not in previous 4.0 releases. But if you do run models using Triton Inference Server, and you can click inside there, the TRTIS repo with that folder on the right.
I wonder if we can increase your font size in there a little bit. I know we've done Control Plus on there, but if you can go to your settings, the Ubuntu settings, I think we can turn on large fonts, but I don't know if that actually works in this. So I think if you click in your that icon at the bottom left-hand corner, maybe, we can go to settings in here somewhere. Universal
Preferences.
access. I think universal access actually is what we want. If you go up to that.
Oh yeah, I see it.
And then what's that say? What have we got? I think there should be like a. Oh no, maybe not then. No, that's not what we want.
Right.
Now we've probably got that. We probably can't get rid of it. Oh, that big X will probably get rid of it. There's go to settings. It says settings and then universal access and then the seeing section. I don't see a universal access in there because everything is quite small. Isn't it?
It's only on board. It's only got on board.
It's Debian though, this isn't it?
We can. Pete, we're almost done with this particular session.
Okay. So if that was going to be quick, it's fine. Yeah, don't worry. You carry on.
Yeah. I guess the thing to note here, you'll see that for the TRT samples and stuff like that, there's more going on here. So like if you click into like the SSD Inception V2, one of those, you'll see here, this is going to give you the repo of the training data as well as the models that can be used by TRT. Unfortunately, that won't be what we'll look at today. In fact, this folder is not fully populated because there's a script that you run that fills this out. I don't want to confuse you all, so we'll go ahead and head back. What we'll be looking at today is primarily cafe model execution, and we'll be using configs one directory up if you go to that configs folder. And this will be where we will do our magic. So you'll see it has examples for Deepstream or Deepstream App TRTIS. Obviously, the difference there being, are we using just the regular compiled Deepstream or Deepstream with Triton Inference Server support? So we're not going to use Triton Inference Server since you are on the 2 gig nano model. I'm not sure that it handles that. So let's go ahead and take a look at the Deepstream app configs. And what makes these up is a couple of things. You'll see here, there's a few folders in here that say things like source, etc. underneath it. I'll help you sort of decipher what those mean. Like you'll see one, it says like source to USB. That means like, or CSI USB. That means we're using 2 camera sources, one on the CSI bus, which is the camera serial interface, one on the USB, decoding inference using ResNet or whatever it happens to say there. So, so that y'all don't have to struggle reading this text anymore, we're going to go ahead and do the rest of our work inside of the terminal. And I know we can bump up the font size there. So, but we can keep this folder just in case at some point, Cliff, if it makes it like easier to go back and forth here to edit files, like you'll probably want to park in that particular directory.
So this LX terminal, yeah?
Yes, yes, sir. And what we'll do is we will CD to /opt/NVidia /Deepstream. Tab is going to be your friend here.
If he's got a tab button. Why not even have one of them?
Oh, OPT, sorry. OPT, yeah.
No.
Yeah, you'll want to just tab complete that. Yeah.
Yep. Now what's next?
And NVidia.
Yeah, is there? Oh, there we are. Perfect.
And then Deepstream. And then let's see what your options are. If you just hit tab, it should tell us. Oh, and we want to make this visible.
Let's
Deepstream
and Deepstream 5.1.
Let's fix the text here.
Yeah.
I think if you click,
I'm going to edit.
Oh, there we are. Zoom in.
Yep.
Control plus bit. Oh, wait.
So it's shift control.
Probably do that. Yeah.
I'm going to have to do it in there because I need shift to get to the plus key.
Bear with us. Yes.
I am using a miniature key. Next week I will be at home in my workshop with everything there and a bigger screen so I can see everything that's going on. Is that big enough, or do we want to go one more?
One more wouldn't hurt. Wait till we ask you to exit VI with that keyboard. Then you're really be in trouble.
I did that earlier. I found the escape key. I was in Vim earlier and trying to get the VNC connection to work. And I was like, right, I need to hit escape, and then it's this funky key. I got it working in the end. But if you can't exit Vim, you can't call yourself a software developer. That's all I can say.
Right. That's right.
The power button exits Vim. That's the best way.
At this particular junction, as you recall, you can really go into the Deepstream or Deepstream 5.1 directory, either or, because they're symlinked. Or Deepstream is symlinked to the same path. So and then I think we were in samples.
Yep.
And let's see what the options are there. Configs. Yeah, let's do configs.
Yep.
Okay, so hit enter there, and then let's do a directory listing, ls, to see what's in there. Oh, we need to go one more into Deepstream App, and then we'll ls that.
All right. Okay.
We're making good time. We're about to see something on the screen here in just a moment.
Woohoo.
Okay. So the first 5 things that you see there, the config infer primary and config infer secondary, are the configurations for the what's called a PGIE, or a primary GPU inference engine in the case of primaries, and for secondaries, as they're called, SGIEs, secondary GPU inference engines. And that will tell you what is the batch size that I want to use for when I send this over for inferencing. It'll tell you the name of the model, the path of the model, and things like that. Where the actual configuration of a Deepstream app occurs is underneath that, all of these things that say source 12, source 1, source 2, etc. And I'll try deciphering one of these or a few of these for you, and you'll kind of get the idea. So source number is how many input sources it's going to take in. So you'll see there's a crazy one down there that says source 30, which means take in 30 video. That probably won't run on the Nano 2 gig. Run those at 1080 with 1080p input, decode using ResNet with a tracker and a secondary, see where it says SGIE, using a secondary GPU inference engine and a tiled display. I'm saying this out loud, and it's going to make sense as we continue. What we'll probably be looking at is the source 1 and source 2, although I believe we can go all the way up to the source 8 Nano example that you see down there. So there's that source 8, 1080p, etc. Okay, so if you open one of these, and I don't care how you do this, you can either use it might even be easier to use the file explorer right now, because that'll not put us in Vim. Normally I would suggest to use Vim, but
I'm a Nano fan.
You're on the world. Yeah, or Nano. So let's go ahead and open up inside your folder, which is the same directory we were just looking at. Go ahead and open one of those source 1 USB. Let's go ahead and open that one, because I think you brought a USB camera, so this one will be pretty.
I've got a Raspberry Pi cam, which is the CIS cameras, and I've got a USB camera.
Oh, well.
So I've got both.
Let's open source 2 then. Source 2 CSI USB, because we can use both. Are they both plugged in?
They're not plugged in at the moment, no.
Okay. Well, this will get us set up. So I think that'd be a cool stretch goal. Can we, in the next 50 minutes, get both of those cameras running? Probably.
And if it's anything like the Raspberry Pi, you have to enable that CSI port, don't you? So it might be that you've got to reboot the Nano to get that to work, but that's not a great problem. But bear that one in mind.
Okay. At the very least, we can always comment out the CSI part, get USB working, and then come back. So let's go through this, and I'm going to go ahead and send a really, really useful link over to Pete, so that we can follow along here. So what's going on in those configuration groups inside that file. So Pete, I'm going to send you this link to go ahead and drop in the chat, because this is going to definitely help people out. This is the Deepstream reference guides, and then it's particularly looking at what's called the configuration groups. Don't worry, Cliff, you don't need to have this open on your side. I'm going to sort of co-pilot with you.
Okay.
I'll leave this open for me, so I can sort of maybe better explain some of these things using NVIDIA's criteria for defining. But as with most things we've done so far, I kind of have my own way of doing this too, that makes some certain possibly incorrect assumptions, but it does get you there faster. So looking at the very first section, you'll see there's an application that says enable perf measurement. Okay, so the first thing that does is that will indicate whether performance measurement is turned on or not, which effectively means do I want to output the frames per second that I'm getting? The second piece that you see there is that perf measurement interval, which means that how often do you want it to perform that measure. And then you have the KITTI output directory. That is, if you do have that enabled, where is the directory that it would write that output to? And what that essentially is, it's a format that you'll see this shortly. When the Deepstream application runs and starts telling us detections, if we did want to store those off into a file, you could set an output directory there, wherever on your host system, and it would write it to that. The tiled display is, and I know we haven't seen this yet, but when you run a Deepstream app, it's going to show you the videos playing, or if those are live RTSP feeds, it would show you those live feeds coming in. And it's going to give you a layout that's defined in this section. So what this is effectively saying is, I want one video on one row, another on another, because we have 2 rows and 1 column. Makes sense. And I want those of a width of 1280 by 720. So it does do this in a uniform grid-like fashion. And you are responsible as the developer to tell it how you want it to see things effectively. The magic part here that you'll see is this source 0 and source 1. Now, I've got a feeling this might just work if we disable the CSI camera. So
you're not going to be able to do anything at the minute. It's read only at the moment, that file. So bear that in mind.
Yeah, you have to save as. You have to save it something different, don't you?
Yeah.
Oh yikes! Yeah, or I guess interesting. Or
But we just save it so you can go into that's what I was looking at earlier, and we can save as.
Oh yeah. Let's do that.
We can edit it, and then we can leave the default as it was and save it as our version. So
here's what I would suggest doing. Not that it's that important, but if you set source 0 to enable equals 0, that disables the CSI camera.
Yep.
Now, bear with me here, folks. To decipher this, it almost essentially is what it looks like. Now, the link that Pete just gave is going to explain all of these things in gory detail in case this doesn't stick right now. So you can always go to that resource. But notice there under enable, it says type equals 5, and it sort of gives you a comment that explains well, type 1 would be a V4L2 or a video for Linux camera. 2 is something called a URI. 3 is something called a multi-URI. 4 is an RTSP, and 5 is CSI. So because this is a CSI camera, we would specify that as type 5. And then down here it sets what the width and height would be. And then the FPS, this absolutely depends on what type of camera you're using. And sometimes you do need to modify that. So that N and D number is the numerator part of the fraction that specifies the frame rate requested by the camera. So in this case, and similarly, the D is the denominator. So what that is effectively saying is I want to pull 30 frames per second from that camera. And then you have a sensor ID. By default, the Jetson Nano only has a single, it has 2 CSI ports. One here and one here. Well, I don't know why I didn't notice that before. Surely I've been aware of that. But if you look there at the CSI sensor ID, 0 and 1 would denote which CSI port you're talking about. So you could have multiple CSI cameras in this case. Similarly, if we go look at the example for source 1, the only thing that really changes here is that we set the type to type 1, which means I'm using a camera V4L source, which essentially means a USB camera that is compatible with video for Linux. Again, frames per second is set to 30 if you look at the numerator denominator. And in this case, it's setting the V4L dev node to 6. That we might need to change. So, Cliff, go ahead and plug your USB cam into your device real quick, and let's probe what its device node ID actually is. There's a couple ways to do this. Just let me know when that's plugged in, and we'll.
Plugged in.
Okay, so like the cheap way to do it, if you just don't know a whole ton of Linux commands and you just like, you want to just get going, head over to your terminal. And what I'll do usually is attempt to see what I can autocomplete on /dev/video blank. So like, if you just type in /dev.
Wrong keyboard. There you go.
/video, and then attempt to tab complete that.
Nope.
Yikes. I'm sorry, you might need to put a command in front of that. Put cd space /dev/video. See if you can, see if that tab completes.
Nope.
Ooh, you might not have a V4L compatible camera. Let's see. Do this cd/dev and then hit tab.
It's gone straight to put another slash in.
And there's.
There you go.
Okay, there we go.
V4L.
Type V4L. Normally it'll show up there, but it's possible that it is. And then hit tab there again.
And it's giving me by slash.
Well, you may not have a compatible camera. Let's just double check that before I come to that conclusion.
We have the CSI full.
You can try to see if there's anything. Yeah, you can see if there's anything in the by path directory, but there's probably not. You would have already seen something.
I was pretty sure this one is, but
Oh my gosh! I realized why just now. Dev video 0 is not a directory, and we use the cd command. Type ls here. This will tell us the answer. It looks like you have one on video 0. So cd .. space .. Sorry.
There you go.
And ls here as well, just out of curiosity. cd .. one more time and ls there, and you're going to see you should have a video 0 there. Aha! See, this is the problem. I told you to use the cd command. I should have told you to use the ls command. That was looking at. You do have. I still don't see video 0 here.
Oh, it is. Scroll down. It's on the right-hand column. I saw video 0. Keep scrolling down a bit more. Keep going.
Oh, thank you.
Keep going. There, look, right-hand side.
Oh, yeah, there
yes.
There you go.
So the fact that exists there, but there's also another command you can do. It's like v4l list. I want to say. Let me look for this. That's the easy way to do that. So. I'm sorry, I gave you a silly command. What I normally do to find what video things are on my system is I will type ls space /dev/video and then tab complete and see what it shows me.
Yeah, it's got video 0.
And in your case, it only gave you video 0. So, but if you had multiples, it would give you multiple options there. I guess it's not important. I'm like scanning for this. How else can you find how to find video for Linux?
Yeah, somebody says they can install the V4L utils on Stack Overflow here. Then you can do a V4L2-CTL-list devices, and it'll tell you a bit.
Yes. Okay, so thank you for posting that. But again, like you don't need to. Again, if you just ls dev attempt to complete. So What that tells us is if we head back to your config file, you should be able to set that node to 0, the dev node for 0 in source 1.
Mouse catches up.
I don't know why.
Starts playing ball.
Oh, down a bit, down a bit, down a bit, down a bit.
I don't know why they
There we go. Oh, no, too far.
set.
It's
And Pete, I'm sure you're seeing this right now, and you're like, "Man, Paul, that class I took with you was way more harder to do this sort of thing."
I mean,
as you're sort of seeing,
I watched for a lot of that, didn't I? Because I had a few different problems, so I found it extremely hard for my own personal reasons.
So if you scroll down here, so sources are inputs, and sinks are like where those inputs get processed, essentially. So if you look here, it says sync 0, enable equals 1, and you have these different types. Fake sync is a sync that does nothing, because you do need to have a sync if you want to do things like just get the output. So fake sync exists for a reason, but it doesn't do anything. EGL sync means that it's going to create a window that has a minimize, maximize, and close button. 3, file output format means it will write the output of the tile display with annotations, etc., to a file like an MP4, and you'll see an example of that below. Number 4 is super cool. It can actually spit out an RTSP feed, so you can catch a live feed of what Deepstream sees in addition to the annotations and overlays. We'll see an example of that. You'll notice that this one is set to 5, which is overlay, which what that means is draw directly to the frame buffer, which is cool if you don't mind having your screen occluded by the application the entire time it's running. And there's some reasons why you might want to use that. So like, think about like if you wanted to set up a kiosk application that like the only thing you want people seeing is the frame buffer of what Deepstream sees. Another good use for this is for diagnosing that your X11 windowing system is properly being forwarded or accessible from a container. This is going to be a problem next Thursday, so I'm just alluding to that. One of the easiest ways to say like, is my Deepstream config good? Is you just go, well, let's switch over to overlay mode and draw directly to the frame buffer and pray that that works. The problem is that's going to occlude your screen, and you're not going to be able to like close any window. So let's go ahead and change sync 0 to type 2, because that's going to give you buttons so you can actually close it on command in this case.
so
This is not going to be a problem, because what we're about to run is not going to be running from container land. It's going to be running from the host. So you will not have the problem that we will see on Thursday. If you scroll down, you'll see a couple additional examples. Like I said, the type 3 for file output. So you'll see that sync 1, which is disabled, and we'll go ahead and keep that disabled. Determines whether we want to output an H.264 or H.265, what the bit rate is, etc., and what you want to name the file. It's not too difficult to understand that. For sync 2, oh, and by the way, you see that source ID number? You might be wondering, what does that mean? The source ID number is just something that you attach to that for metadata later on. It's arbitrary, so it's not super important. The sync 2, which is also disabled, and we'll leave that, is how it would serve the RTSP stream from this device. Now, the way that this works by default is it serves it up over a endpoint RTSP : the IP of the device /ds-test. The only way you would know that is if you read the resulting README that goes with this, but that is what it does. But you can see it's very easy to say, I want an H.264, H.265 RTSP stream. Here's my bit rate. Here's the ports I'd like you to communicate on or transmit the UDP data on. Finally, we're getting close to the final area. You'll see the on-screen display. This determines the text size, color, background color. We can change those, and those are given in a specific color format, and they mention this in the documentation. Let me see that. It's like you'll see things like where it says like text color. This is using RGBA format. So if you did want to change those, you totally could.
I was going to change that and up it a bit, maybe. There you go. We've got 24.
Oh, sure. Yeah. That wouldn't hurt. And that'll make the text for any object detections a bit larger. Stream mux. So you'll see here, this tells it whether it's a live source or not and what the batch size is. Batch size should usually be equal to the number of device or number of input sources. So because we have a CSI and a USB source, we would set that to 2. Even though we've disabled one for now, let's go ahead and leave that set at 2. Down here, it says primary GIE, which is the primary graphical GPU inference engine, sorry. And this points you to what model engine file it's using. A model engine file is, if you want to think about it, when you open a cafe model in Deepstream for the first time that it has never seen before, it will transform that using TensorRT, which is a proprietary parser for tensor models. It stands for Tensor Runtime. It's created by NVidia, and will produce a engine file. It is a one-time hit that you will take the first time you run it to produce that. And once it's produced, it'll always use that. Essentially, you can think about it. It's like when you compile code, like you get a built thing that just works. It is transforming the cafe model into TensorRT format in an optimized fashion. Once you have that engine file, it just runs fast. You'll see again the batch size is mentioned, and it tells us that the config file that it's using is something called config infer primary.txt. And we're going to come back to that in just a moment. So we'll scroll down to the very last things here. So you'll see where it says file loop equals 0. If you are running video input sources, so we're using cameras. We're using a CSI camera and a USB camera in our configuration. If you were using a MP4 file as input and you wanted that to continuously loop, you would set that to a 1. So, think for like a demo or something like that. Hence why it falls under the tests section. And while that is not all of the configuration groups, that is most of them. Let's real quick go look at config infer primary text. Then we'll come back here and save this.
Was it that one? No.
This should be in the there. You should see it all the way up in the upper left. Config infer primary text. So this file is also being referenced by that configuration. And if you scroll down here, what this is, without confusing you all too much, because you can have multiple configs for inference engines, but only one for a primary. So you can only have one primary detector, but you can have, I believe the documentation says, infinite secondary classifiers. So to your heart's content at that point.
So by that, you mean your primary would be you're looking for cars, and then your secondaries could be the color of the car, the model of the car, all that sort of stuff.
Yes.
Is that what you're saying? Yeah. Okay.
Yeah. And so you'll see here the model, like this is the configuration for the actual primary detector. So it's looking at things like the model file itself, meaning that cafe model, the proto file. And where it says model engine file, that is the name that it will give the model engine file when it is parsed by TensorRT. It's going to be interesting to see how this works, because for whatever reason, the batch size is set to 30 on this. That should probably be decreased, but you'll also notice an interesting nomenclature here where batch size is set to 30. If you look at the name of the model engine file, it says B30. Normally, you want to designate what the batch size is that you're using. What we mean by that is when this model takes in input frames, how many of them can it batch simultaneously? And so this is saying that this thing can handle like 30 frames in a single inference run. It'll be interesting to see if this works without modification. It should. Down here, there's some additional things as well where it tells us we're using a network mode of int8. So that's going to use int8 fidelity during the when it's actually calculating tensors and that sort of thing. The number of detected classes in this model is 4. If you want to know what those 4 things are, there's a label path that says labels.txt. There's a file probably somewhere inside that models directory. I'll ruin it for you. It's, spoiler alert, it's people, vehicles, bikes, and road signs is what it can detect. And you'll see down here just a few other interesting things here, what the output blob names are for convolutional 2D bounding box, convolutional sigmoid. You'll see a bunch of other things that are commented out there, like parse bounding box function name. That means like if you're using a custom library, which we're not in this case, you can create a custom parser that will use custom logic to parse the bounding box itself. Because maybe you don't want a square bounding box, maybe you want a circle. So you could create all of these libraries, everything that we're working with is completely modifiable if you're comfortable in C. That's a big ask there. So if you go all the way down at the very bottom here, there is a directive that says class ATTRs all. What that is saying there is that for all class attributes that can be found in this model, we're going to use a confidence threshold of 0.2. So if it detects with 20% confidence, which may seem like a low number, that's actually not too low for an object detection algorithm, we're going to go ahead and count that. And then it gives you some different things like region of interest, offsets, detected minimum width, height, etc., and detected max width and height. You can also do per class configurations. So if you were to open that labels.txt file, I believe the very first thing at the top of it is a person. And so that's going to be in another directory.
It will be, yeah.
Yeah. But to make my point, assume that the first one's a person. You'll see down here they have a class ATTR0. That designates what is the first thing that the primary detector can see. And if you were to uncomment those, you'll see that you could set a more specific threshold of confidence for that particular class, all the way down to classes 0, 1, 2, 3, and 4, or 0, 1, 2, and 3, because I think it, yeah.
It's zero based.
So let's go ahead and save that configuration.
We've not edited this one, have we? So we don't need to save this one.
No, we shouldn't need to change that. We'll go ahead and change our Deepstream config.
So we changed this one, so now we want to save as.
Maybe give it.
Do these configs need to be in the specific directory, Paul, for them to work, or can they be in your home directory, or what?
There are some path considerations. I mean, you can run a Deepstream config from anywhere, but just make sure that if you're doing like relative paths to configs, which I think these do, like they're not specific. You just need to pay attention to that. But the takeaway should be, Pete, that you have a overall config for the app itself that determines the sources, the inputs, and the outputs. And you also have a configuration for any of the object detection models that you would be using, or your inference models, the config infer portions. As long as you have those set up in the master config where they can see each other and it can get everything it needs, you're good to go. In fact, next Thursday, we'll be running configurations from completely different paths than these. So
I was
Totally
worried it might
possible,
do
but
that,
just
Cliff.
keep it in mind.
I think we need to
usually
we need to do a ch mod on that directory. I think potentially. Hopefully, we don't
Yeah,
need to change the
yeah.
owner. So if we can get back to just above that directory, ideally, wherever that was. Where is it? It's in opt, is it?
yeah, it's where we were earlier. CD/opt. Yeah, because we're in /dev now. /NVidia. In fact, what we could do is just chmod or change ownership on the whole NVIDIA Deepstream directory. That probably wouldn't hurt.
Worried about changing ownership in case it runs its own service or its own user or something, and then it can't gain access to it for whatever reason. It's probably read only at that point anyway, but I don't know if it's got temp files and stuff.
If we change ownership recursively on the directory, that should solve that.
So you want to do it here, yeah?
No, not here. Go into the NVIDIA Deepstream directory, and we'll do it there. Or that directory. Go there, and then we'll do it on the entire. So then it's ch own. Let's see who owns it first. I'm just curious who owns the Deepstream directory. Let's just see who that is. Sorry. Do an ls minus l or ls space dash l. See who owns it.
Oh, dash
space
L.
Dash.
Oh, yeah. Sorry, ls
space
dash.
Yeah.
Root owns it all. Mm-hmm. Okay, so you're going to have to do sudo chown dash space dash capital R
for recursive.
Yes. Then your username : your username again. CA software : CA software.
Colon.
Three different keys. There we are. It seems to be working all right, this little keyboard, though. I'm quite impressed.
It's a brilliant little keyboard. I've used it in the past, but yeah, doing it on the live stream. Normally, I'm doing it in the back of the mobile sim or something like that. But yeah,
I'm trying to remember. It's either you either put. I think you put /Deepstream at the end of this. It'll autocomplete for you in any case. If you type D tab, it should autocomplete.
Or space.
Oh, space.
Oh, sorry. So I'm trying to.
There it is.
Yeah, that'll do it. Yep.
Just enter that, yeah?
Yeah. And then your sudo password, and that should fix this all up.
Whatever that is.
Done. And then do ls minus l just to sanity check this. That worked.
Yep.
There you go.
Now you own it. Okay, so let's see. Yeah, you might not need to change the. Well, I guess it doesn't hurt. That way you can always look at what was there before. So you should be able to save in that directory.
Yeah. It doesn't say read only anymore.
Here, isn't it? Yeah, it's not read only, so I can now just click save.
Oh, do
you
want to
overwrite it? In fact, I'll rather than overwrite it, I'll save it as a different one.
Yeah, good plan.
Yeah, not a bad idea.
Trying to type on the wrong keyboard again.
And I think this is going to work, and we're going to get this like right on time. I think it's going to work. Okay.
There we go. Done.
So here's how you run the Deepstream app with your configuration. Go back to the terminal and just type deep tab. It should autocomplete the Deepstream app. It should.
Yep.
app space -c for config. Hit enter. This is going to fail.
Yeah, we're in the wrong directory.
I want to make this easier for you. Navigate into the config directory from here. So cd Deepstream.
Oh yeah, right, yeah. Deepstream. Is it Deepstream? I can't remember what's it now.
Yeah, either or.
Ooh.
And then I think
Johnny Depp stream.
Wait a minute. No, you should be Deepstream/samples, I believe.
The sample is going to be in this one, isn't it?
Is that auto completing?
No, it's not.
Yeah, it should be samples there. Yeah.
Yep, there you go.
/configs. Enter. Then hit up a couple times to bring back your Deepstream App-C.
Yep.
And then type source2 tab.
Source2
tab.
TAB, yep.
Oh, no. Hit the tab button.
Sorry.
Sorry. That's, yeah. Could have been more clear when I said that.
That's not...
that's not auto-complete.
No.
/source2, sorry. What's that?
Nope.
Oh my gosh, we're still not in the right directory. We need to go one more deeper. The Deepstream app. Yikes. Yeah, CD Deepstream app. Don't worry, we're going to make this work.
Forcibly.
Oh, dash app, sorry.
It's dash app, isn't it? Yeah. Just spread that after I hit enter. I'm looking down at the keyboard because it's so small. You have to look at it to see where it is. But yeah, now I go up.
Okay, now, yeah. Now that source 2 should auto-complete.
That one there. And now it's, is it /source 2? There you go.
And then underscore for yours. Add the additional underscore.
Yeah, we changed the name, didn't we?
IoTeaLive, wasn't it?
Yes, that should autocomplete too. Yeah.
Yep.
Now hit enter.
Oh, something.
In a not supported by platform.
It's only a warning, though, isn't it? You would have thought it's still going to carry. It's doing something. Your CPU shot up in that little.
Yeah, you can see. You can see down the bottom in the little.
Oh, and those are just warnings. They're fine.
You can see the CPU's down in the little graphic down here. The CPU's doing some nut stuff.
Let's stop
It
now.
should work. Yeah, so it's going to build that. Remember, the first time you run, it's going to take a huge hit on building the engine file.
Yeah.
So
it's doing something.
Exciting. And it can take minutes for this to success. So let's. I do see though it is saying that it is attempting to use that B30. I don't think it's going to matter. We'll see. Because technically your batch size is 2 because you're only using 2 sources. But...
Actually, it's complaining that an open error on that. Interesting.
Sometimes.
So when it finds that it doesn't exist, then it goes into this mode where it actually builds it. That's why we're locked up at the moment. It's that one time sort of hit.
So some tactics do not have sufficient workspace. Okay, so it's doing some stuff. Oh, hold on.
Hey.
There we go.
Yeah, that's my hand. Hey.
So if you should be able to detect now this is their model, so like it's gonna work as well as they trained it, which I can't say is perfect.
You might need to close your curtains. That'll do that. That'll work. Yeah, turn around.
Yeah.
Well, you would think. Cliff, that should totally see you.
Take your headphones off.
Brought in action.
Oh, it did it. It did it just as he took them off. Actually, it said person.
I saw that for a second.
No, I was longer.
There.
Oh, you see it there. It said person.
Headphone person. Okay.
There I am.
There's 2 people. That's cool.
Now,
I think it's because it's cropping a little bit.
What we are victim to right now is NVIDIA's model and how well it is trained, which these are samples. So it's very likely that it probably overfits the sample video files. That's my guess. But on Thursday, well, I don't know if we'll have enough time. We can throw. We're like basically almost at the point, like all ready to start using cognitive. There we go. Yeah.
I think I'm just too close to it. I've just pulled over the furniture. I'm glad I made the bed this morning.
Yes. You didn't see
I left it in, but yeah.
You look civilized.
Yeah.
It's not like not what my hotel rooms look like.
But it's seeing me. Yay!
Yeah.
Yes.
Sort of.
Perfect.
But not a road sign or a train, so that's good.
So Cliff, and you see here too, right? Because we set the tile display to 2 rows, you have 2 rows on this tile display. Yep. Because we set it as EGL, you have the minimize, maximize, close buttons. The next steps here, there's quite a few things to go through. You can plug in your CSI camera, so then we have 2 cameras to have fun with. On Thursday, once we get this rocking and rolling with the power of Azure IoT Edge, we can probably start throwing cognitive services models at this, which is not as straightforward as you would think. It's not like you just export a cafe model and it just works. We're actually going to use a custom parser. What else will we do? I hope we'll have time for that. We'll at least get it instrumented under IoT Edge. And I love that you have this config file, because we can actually use this same exact config file for when we transfer this over, or at least portions of it.
Cool.
The only interesting pieces, being quite honest, are your source inputs, so the USB cam and et cetera.
Yeah.
So that'll be fun. We'll be slaying some pretty big dragons there too, because remember if we do run this as a container on Thursday, it's going to need access to the X11 socket. It's going to need access to, if you're using the CSI port, it needs some access to something called an Argus socket. So we'll look at those things. But the takeaway today, sorry, without getting too far down the weeds of what we'll do next time, you should understand, for everybody that's like watched this today, and Cliff going forward too, this is the big piece to keep in your mind. You now know how to wield the samples and the configuration-driven approach to set up a Deepstream application. If you were to like explore this further, while you're in your hotel room, I would totally suggest like seeing exactly what existing configs that it has there. You now know how to do that Deepstream app.c, pointed at whatever. See which ones you can get away with running on there, because I think there is that one that does 8 videos simultaneously. In fact, try running that one right now if y'all just want to see that. I think that'd be a good closer. Yeah, let's give that one a go. And then that should give us some time to just debrief. I'm kind of curious what your thoughts are in terms of what we learned here, and just glad to see that this is all successful, especially as you type on the world's smallest keyboard.
Yeah, I mean, the keyboard is this little thing here. It's yeah. It's I keep going. You got a little mouse pad on the top and everything. I mean,
you have a banana
keyboard,
for scale. It looks smaller than a banana.
It detected something, that I'm
well,
sure.
There's my hands.
It detected something when you did that.
It said it was a road sign.
Bike.
Yeah, that's what I'm saying. That model is guaranteed overtrained. Like,
Thinks it's a car now.
Guarantee it. Yeah. So we'll alleviate that when we take matters into our own hands and build our own models.
So if I close this out, then.
Yeah. So I think there was another config in there. Oh yeah, and there's your perf measurements. It was because we had perf enabled.
Yep. So config in the one up from this, wasn't it? No, this is config.
Yeah, head back to your terminal, and we're going to run one of the source 8 models. So quickly hit LS. Just want to see what's in there again. And we'll do the one that says source 8 1080 deck infer and ends with nano. Let's go ahead and kick that one off. So that'll be Deepstream App -C. You should, if you hit up a couple times, we can just use the last.
That's what I was doing. There you go. Deepstream App -C. Yep.
And then source 8 tab.
Source 8.
And then
tab. There you go.
And then type in the letter N and then tab.
There you go.
And run that. And let's talk, because that's going to take a while. We'll see if it works. I don't know if it'll work. I really don't.
Paul, how much?
What's this one doing then?
Oh, go on.
This will do 8 simultaneous streams using their video, so their model will make a little bit more sense.
Okay.
It's definitely overfitted to their training set for sure. But yeah, this is going to take a few minutes. So let's debrief while that goes, and hopefully we can sign off with 8 videos simultaneously processing.
Paul, how far?
This thing's not got hot at all. So.
Oh, that's impressive. Hey, we'll do now. How far away from your class is what we're looking at here? What did you have to do to get to your class from where we are today? And obviously without deep diving too much, but is there a whole heap of stuff you had to do? Or
I would say that the class, like what we just did, arguably, you could get away with without understanding what the hell you just did, like to some extent, right? Because it gives you a mostly complete config file, and you're changing some things here and there, but you're like, and you might think that you're a savant, but you're actually missing wow, this really works. And I would say that what the class teaches you is it goes more into like, here's the C library and the actual C functions that are getting called underneath the hood, which also arguably has the commentary to be made of, do I really need to know all that? So I think it's good to strike sort of a medium, as with most things, it's like, if you're a .NET developer, it's good to know the CLR exists. That doesn't necessarily mean you need to write a raw parse. Yeah, there we go. So you got 8 streams, and the detections to make more sense here. But what's crazy is you're doing that on a 2 gig of RAM device that costs $60 USD. That's what's crazy.
Yeah. Mm. Yeah, I mean, imagine that being like 8 separate cameras fitted up around an office block, doing pupil detection and the likes. I mean, that's on a device that is drawing, I think it was 100 milliamps at 240 volts is what the charge is taking. So, I mean, it's ridiculously low powered for what it's doing.
This is the GPU that's giving you this power, isn't it? I mean, the Raspberry Pi just can't do this because the GPU's not as powerful. So that's where it stopped. But yeah, that's where the difference would be there. So
if you set file loop to 1 on that one, you could keep it perpetual. But up to you.
Yeah. That's super impressive for a cheap device. I mean, the whole setup. I mean, it's got $60 USD for the device. I can't remember what I paid for it in the UK, but then I spent maybe $20 on this micro SD cards. And I think the USB-C charger that I've got, I think that cost me about it was certainly only £4 or £5. It wasn't expensive that come with it as well. So you're talking, about $85 all in, $90 maybe, and you've got a device that can do this. It's impressive.
Oh, it's totally. So for next week, or if people are just wondering like what to do next, I would totally suggest we had sent out, I'll pass a few links over to Pete here. We sent out the Deepstream documentation that shows the sample configuration groups, how you can actually modify those essentially. Also, the Deepstream Getting Started guide would definitely suggest that, which will sort of show you, how to get started with this, a bit more advanced configuration. What we'll do next week, we're going to look at the AKAMS Intelligent Video Analytics project and go a little bit more like, how do you take what we just learned here and turn that into something production ready that you could back with services in Microsoft Azure for basic, reporting of telemetry, visualization. We'll also even hint at, I don't know how far we'll quite get in 2 hours, but we may be able to get all the way to the point of like making our own object detection model that we can train with our own samples, and of course give it even more context because we can use tools that are available there. So everything you've seen today, I mean, this is not smoke and mirrors. If you did want to do 8 simultaneous feeds, whether those are coming from the internet or locally, those will work. So we're set up at this point. We know what Deepstream is. Let's go to production and productionize it next Thursday. That's the idea.
Sounds good to me. Yeah.
Cool.
I like it.
It's very, very cool.
That's practically the end of the stream, as Paul's just alluded to there. Thank you so much to Paul DiCarlo for coming along and entertaining us today and getting Cliff up and running. And well done, Cliff, for all the effort, because that wasn't straightforward.
All via my mobile phone and the hotel Wi-Fi, and it worked. So just want to, that's... Yeah, we're proper IoT. I need to put the hotel TV back together because I was using that earlier to get the Jetson set up, and there's cables hanging out of the wall at the moment, so I need to plug all that back together, so I don't get fined by the hotel. But yeah, it's been fun. I really enjoyed that, and I'm going to go grab some breakfast because I've not eaten yet, and then I'm going to sort of play around some more and see what else I can come up with. I'm going to see if I can plug in this Raspberry Pi cam and get 2 streams working, and see what we can do from there.
Don't forget, I think we disabled the CSI cam, so don't forget to go back to your config and
yeah, no, I wear that. Yep, I'll go back and do that as well.
Excellent. So next Tuesday, we've got Jose Samoes, and apologies if I've pronounced your last name there wrong, Jose. Jose is the founder of Nano Framework. So this is being able to run .NET on microcontrollers. So that's going to be an interesting session. Talking about that, and then that's at 9 p.m. BST on the same Azure Live Twitch channel, and then we'll be back here for the second episode of this workshop series at 2 p.m. BST again on the Azure Live Twitch channel, and then actually in the evening following that, we've got Andrei Podnosov talking about Azure Digital Twins at Knots IoT, and that'll be at 6:30 BST on Zoom and YouTube. So you can find us on the internet there at notsiot.co.uk, although I've not actually put any of the latest meetups on there, so meetup's always a better place for that. I just need some more time. I need 2 or 3 more of me to be able to do everything I need to do. But that was really cool, and I'm looking forward to seeing where we get to next week with some of these bits and bobs. So yeah, excellent. So thanks everybody for coming along. And we'll see you again soon. Thanks, everyone.
Bye.